Hello, we are from group 38 and we are going to present about secure AWS migration project. Our objective is to take a highly vulnerable legacy system and completely re-engineer it to secure posture using a modern cloud infrastructure network. For the next slide, um, the legacy problem is that we inherit a single server alumni application running on a completely flat network, crippled by hard-coded secrets, unencrypted data in transit, and absolutely zero disaster recovery capability. A single web exploit would result in a total database compromise, and the architecture walkthrough is that to resolve it by looking at the diagram, we implement a strict defense in-depth strategy across three isolated layers. First, the public tier ingress tier is like the public ingress tier hosts only our application load balancer and net gateway. It contains no application code. Second, the private application tier runs containerized Node.js server on EC2, entirely hidden from the public internet. Third, our database tier hosts Amazon RDS MySQL instances in a completely isolated subnet with zero internet routing. So we wrap this architecture in a matrix: AWS Secure Service to guarantee compliance. AWS WAF sits at the absolute edge of the block. OWSP, top 10 web vulnerabilities. AWS IAM, then instance profiles, eliminate our hard-coded secrets by providing dynamic auto-rotating credentials at runtime. And AWS KMS enforces transparent encryption at the rest of our RDS volume and R3 bucket. AWS CloudTrail and CloudWatch and centralized immutable logs to eliminate local log tampering. Finally, granular security groups and statement NECLS restrict micro-segmentation traffics, ensuring the database tiers only accept traffics from application tier on port 33006. So I'm gonna give this to my next teammate.
Hi, my name is Michael, and today I'm gonna present about what we done in this assignment. So for my part, I will explain what we did in our code site. So basically, in our security group here, this is where we secure our network traffic. So as you can see, we have implemented a strict tree architecture. So we separate the security group for our application load balancer and our application tier and our database tier. So we also configure the ingress and egress rule so that the traffic flow securely, and the internet can only talk to the load balancer, and also the load balancer talks to the app, and only the app can communicate with the database. And this really reduce our attack surface. And then the next one is database, and basically I want to highlight on the reliable and the data protection. So as you can see, we have enabled the storage encrypted and the multi-AZ, which ensure our data is secure, at rest, and highly available across different availability zones. Most importantly, from a security side, you will notice there are no hard-coded secrets in this file. So all sensitive information is dynamically injected using the variable like VARDB password. Yep. So this is to secure our database. And last but not least is the compute TF. So what we're gonna highlight is about the user data block. So basically, this is where our automated deployment happens. Instead of manually configuring the server, this script runs the moment when our EC2 instance boots up. So it will automatically update the system, install the Docker, and then pull our latest containerized application image straight from the Docker Hub and spin it up. This guarantees that our application environment is completely standard and replicable every single time we deploy. And let's move on to the Terraform workflow part. Our Terraform part. So first of all, we will do the Terraform init, which we will download all the required file. And then after that, we will do the Terraform validate, is to make sure just all the configuration is ready for our project. And then after that is Terraform plan. So basically, this allows us to preview all the changes Terraform is about to make in our AWS environment without actually provisioning anything yet. So all of this is just act as a safety check. All right. So the next one, what we do is Terraform apply. Yep, here is it. So basically, Terraform is now communicating with the AWS API to provision our entire architecture from the VPC and the subnet and to the database and also the auto scaling compute instances. So by using infrastructure as code, this entire deployment is automated, repeatable, and completely eliminate any human error during our setup. And then after this, here's our Docker image. Yep, it's just to show our easy, simple Docker image. All right, that's it from me. Let's move on to the next person.
Representing the live application now. This is basically the live application URL, the login portal. So this is basically the directory. The app is basically running on mock data, so it's not a live application. So the flow goes from the internet to our application load balancer in the public subnet and to the EC2 private subnet and finally to our Docker container. Moving on to the AWS console, where in the EC2, in the target groups, we can see that both the instances are registered and healthy across two availability zone. So it proves that our Docker container started correctly, and also we have high availability. For the database network isolation, so in the security groups, the inbound rules show that the database security group only allows MySQL on port 3306 only from the application security group, basically zero access from the public source. And in the subnet, as we can see in the route table, it only has one route, basically a local route. There's no route from to the NAT gateway and to the internet. So in a nutshell, it's basically fully isolated. For encryption at rest, as you can see in the report, this shows the AWS KMS and the S3 bucket that shows the SSE KMS with a bucket policy that denies any non-TLS requests. So the reason that we can only show this in the report, because in the sandbox, the lab role basically blocks recreating RDS and S3. So that's why we can only show prior deployment. And as for encryption enforced by code, you can see that the storage encrypted through is basically defined on RDS and SSE KMS. For audit logging, in the event history, we can see that CloudTrail records every management API call. So for security validation, you can use Nmap to demonstrate. So it shows that a port 80 is only open and port 443 HTTPS is closed. And finally, port 3306 is one of the filtered ports, one of the filtered 998 ports. So basically showing that the database is not reachable from the internet. So in our documentation, there's a few service that was said to be infrastructure as code rather than deployed live. So the role basically enforces the policy that denies creating RDS, WAF v2, and reading S3 blocks. So we basically confirm that it is a policy limit, not an error on our part. So the Terraform plan validated everything, but on the Terraform applied, it was basically denied the IAM layer. So in the multi-availability zone, RDS and the WF rules, it exists in our Terraform, and it will deploy unchanged under a privilege role. So it shows that only HTTP is open. This is because HTTPS is met at the design level. But the public ACM certificate basically needs a domain that the sandbox, basically we don't have one in the sandbox. That's why it is closed. So all our code is in a GitHub repo, and the image is in the Docker Hub presented by Ling. And so after the demo,